Hi guys, welcome to our channel of Sciences and Mathematics. Today we are going to have an introduction to a new topic in mathematics by the name geometry. Now we're going to see specifically, maybe in a summary form, the relevance of geometry in our day-to-day lives and different applications that it's being used in order to advance maybe new technologies or being applied in some areas in order to find solutions to challenges that are facing the society. And we shall also explore different ways in which geometry is being applied and some new ways which have been developed in order to find these specific solutions that we are talking about. So in that case, without further ado, thank you and welcome. So as I've said, today we are going to study a topic in mathematics, which is just right. It's an introduction part. Of course, there are specific areas we're going to cover in this case. Now, this branch of mathematics by the name geometry is very important for us to study because it's going to lay a basis for us in understanding other disciplines which are related to mathematics, like physics, biology, and maybe other aspects like engineering, which we might come across as we are studying all these other subjects, or the specific applications which it is being applied. So in that case, it's important for us to understand first what the term geometry means, so that when we are going to study about it in a nutshell, we understand what we're talking about. So in this case, geometry is a branch of mathematics that of course deals with measurements, properties, relationship of points, angles, and lines, or even surfaces and solids. So in this case, this branch of mathematics, or geometry as a topic, is a branch of mathematics that deals with measurements, properties, and relationships of points, angles, surfaces, and even solids. It is, of course, we are going to see that maybe we might include some ideas, one or two, as we go by, but for that case, in simpler terms, this in a nutshell gives us a simple definition of what the term geometry refers to. So it's a branch of mathematics that deals with measurements, properties, and relationships of points, angles, surfaces, and solids. So in that case, when we're going to learn about what this specific terms refers to, it will assist us understand the relationship between maybe angles and lines, points, surfaces, even solids, etc. So as we have said, this branch of studying the relationship between these aspects is very important because it is applicable in our day-to-day life. Because somebody can ask, what is the point of me studying geometry in real life? So in that case, we're just going to list a few. So this is the role, maybe you can see the importance of geometry. First, we have said that for us to understand the fundamental properties of the physical world, this branch of mathematics is very important for us. So in that case, it assists us to explain explain the universe. So in simpler terms, in that geometry assists us understand and describe the fundamental properties of our physical world. It gives us an insight on what the universe is. So geometry, as well as a branch of mathematics, assists us in learning new ideas or the relationship between different disciplines. So in that case, geometry is very fundamental in assisting us learning new ideas, which of course is going to assist us in advancing in other fields such as sciences, engineering and arts, as I've said. So in that case, it's very important in improving our learning or giving us a deep understanding as we learn new skills. So in that case, of course, for us to develop critical thinking and deductive reasoning, I can just say critical thinking. So in studying geometry and trying to solve different aspects of maybe the shapes, angles that we have mentioned, this one helps us develop logical thinking skills and deductive reasoning, and maybe in the process we can have some analytical skills which are going to assist us in problem solving. So in this case, of course, I can as well say that in some fields like medicine, when we start about geometry, there are some of the applications that we're going to encounter, like the use of machines, which gives feedback in terms of maybe geometrical aspects. So this one will assist the doctors and the personnel in the medical field understand or interpret the shape, sizes, and of course different shapes and sizes of our body organs, the cells, etc. So that one is very important in the aspect of medicine, in that by studying geometry, the doctors are able to interpret the information which are being relayed by medical machines. So in that case, of course, maybe lastly we can talk about the construction industry. Construction industry, this one, of course, geometry will assist us interpret and design structures which are suitable for our day-to-day life. So in that case, as we can see, the study of geometry is very relevant and important in our day-to-day life. That is why, in an essence, it is paramount for us to study that. So there are some specific areas, introductory areas, that we need to cover when we are studying geometry, which are going to assist us, of course, as we said, expand into other knowledge and aspects of mathematics and sciences. So in that case, I will start from this point. Suppose we have just a volume in space like this, and then we have let me just denote that one as P. Now this one is referred to as a point. A point in a sense that this is a location in this particular volume in space. So this is a location, a very small location in space that I've noted in this particular space. So that one is known as a point. So this particular point does not possess or it does not have length, does not have width, and even, as we can say, does not have even the height. So my point that I've just demonstrated in this particular volume does not have length, width, or height, which are the aspects of some figures that we're going to learn as we're going to advance more in geometry. So in this case, this one, we can refer it to as, this is just an alphabetic letter that I've arbitrarily used in that case. So that one we can refer to it as point B. A location in space, a very small location in space, which does not have length, width, or height, we can refer to it as point B. So from that point, maybe, suppose I have another one at this point, and then I refer to it as Q. So in that aspect, the properties of point Q is that it does not have length, width, height, and it's just a similar location in space like this. Okay, when 2 points are in space like that, and we join, okay, let me use this. If we join these points P and Q, just like that, then the smallest distance between, the distance is the displacement from this point up to P to Q. So the distance between P and Q, the smallest distance, is known as a line. So in that case, we're going to see that we have different kinds of lines which we are going to define. For instance, the one I can put, of course, somebody can point this, something can move from this point P to Q using that alternative. Maybe let me say alternative A, alternative B, and even it can decide to use alternative C. Both A, B, and C are known as lines, but the uniqueness of line B is that it's a straight line because it's the smallest distance between the points P and Q in space. So in that case, we call that one a line. And I've said that since it's the smallest distance between P and Q, it's known as a straight line. So in that case, we have said that a point is a location in space, a small location in space, which has no length, width, or height. So let's see about this aspect of a line and try to see what's the difference between a point and a line. So in that case, we have talked about a line. So we are going to use the term line segment. In this case, of course, as we go far, we are going to expand on this, but for now, we're going to refer to the point that I've demonstrated AP as a line segment. So we can use any alphabetical orders to denote the movement from P to Q. It can be from A to B, etc. So in that case, the line segment that I've said it's from point P to Q, the smallest distance between the 2 points, which I've called a line. So it's going to be referred to as a line segment. So it consists of 2 points that of course we refer to as endpoints, which consist of all the points between P and Q. So in mathematics, we refer to this line segment as PQ. So that is how we refer to as the line PQ. So since I've mentioned PQ, that one demonstrates that the points are moving from P to Q, or it's a reference to points from P to Q. So in mathematics, this is how we denote a line segment, so which can be written as PQ. So in that case, if we try to find the length is the distance from P to Q. So if we try to demonstrate the distance between P and Q, so we can say that, so this denotes the line segment, and this one of course is going to imply, okay, let me just put it like this. So we can illustrate the line segment PQ as this. So this one is the line segment, and then PQ, this is the length of the line segment. Forgive my handwriting. So that's the length of the line segment. So suppose maybe this is just a part of we can have a line segment or just a line. Just just use this. Suppose PQ is part of a continuous line that runs infinitely. Infinitely means which is that so that's no end, it just runs continuously towards the both sides. So suppose this is PQ from the point PQ that runs infinitely, then we are going to define the second part of the line that I've said, that this is a segment of this particular line. A segment, which means, of course, a portion of that line. Then we are going to denote PQ like this. You see that, remember the first one we said that it was PQ, segment PQ denoted as an arrow going towards the right from P to Q. So if the line runs infinitely on both sides, on both sides, then we are going to denote it using that particular way. So that is how we denote the line PQ. So then we can ask ourselves, what basically is a line? What is a line? If we have this one running infinitely, then we are referring to as, of course, PQ. And then this is the distance between point PQ, noted as PQ. Of course, this is a line segment. And then the length, we have said that we can denote the length of the segment by just stating it as PQ. Then what is that? What is a line? How generally can we define a line? So in that case, we can define a line as a set of points which extend infinitely in both directions, and it has infinite length and a zero width and height. At the beginning, I said that a point in space, an arbitrary point in space that we had written as P, has got no height, width, or even length. But for a line, it has length, but zero width and height. Of course, when we are talking about width and height, we shall define that one in details when we are talking about especially volume. And that one is going to assist us to illustrate what the aspects of width, length, and height means. The last bit of the definition for geometry, we said, is about the study of the properties of even solids. So since this one is a solid, that is where the aspect of width, length, and height comes from. So which means, in this case, this line does not possess height, and it does not possess the width that we are talking about here. So in that case, it only possesses the aspect of length. So that's a definition of a line, that is a set of points which extend infinitely in both directions, and has infinite length and a zero width and height. So for that case, I said that we can, of course, use a different, we have different ways of approaching from point A to B. We can decide to use this one, as I said, different routes, but the shortest distance between point P and Q, we said, is what we call a straight line, which means it does not have bendings, deviations, and maybe slight changes of angles from its point of travel. So it means that one is a straight line. So for that case, we said about the distance between the 2 points as a straight line. Now this mathematically is going to assist us to find or quantify this particular distance between the straight lines. And this, in a sense, is going to assist us develop the basis of fundamental aspects of the geometry we are talking about. So when points lie on a straight line like that, we call that infinite distance a line. And then when we demarcate points on that line, or give it quantity, or give it units, we can call that one a number line. So in that case, suppose we have a, so from basic mathematics, of course, I presume that we understand what a number line means. So suppose we have a number line with the points at 5, and maybe another one this is 0, another one 3, and then we have another one maybe at 20. So then we say that this is point A, B, C, and D. Those are points on that straight line as we had demonstrated for P and Q. So the distance between A and C will be the magnitude of 5 minus 3. So when we are trying to find the distance between the number line for those particular segments, or segments of a line as we just defined, we are going to find that we are going to consider the distance between A and B. This is minus 3. So in that case, this is plus 5, the displacement from this origin that we are saying. Of course, from this particular point, which is a 0, towards this end we have negative integers, while on the positive side we have positive, on the right side we have positive. So in that case, we are going to see that this negative 3, that is the one we get. Suppose we were to find the distance from 20 to 5, this is CD. I'm just giving an analogy of this. So we have to find C and D, just leave this one pending. C and D, we will just get the magnitude of 20 minus 5. So similarly, since we were to minus this one 5 minus, this is negative 3, then the magnitude of this will be 8 units. Only be centimeters, kilometers, etc. So on that number line, that is how we are going to find the magnitude of the point, the magnitude of that line between two different points. And then for that case, we are going also to use this concept now. Suppose this line is this straight line can have orientation of different, or some orientations of different places in space. And as we are going to learn further that we can have a 2-dimensional space or a 3-dimensional space, of course, which gives us an aspect of the Cartesian plane coordinates. Now I'm just going to introduce that one and just use it so that we can be able to use it for demonstration. So suppose we have a Cartesian plane coordinates, so just a Cartesian plane. This is an XY plane, and then we have a straight line of that kind. Maybe let's call that one PQ. Or just we have a straight line, and then we have on that straight line the points A and points B. Then using the example that we had done for finding the magnitude, there's a special way in which we are going to find this distance between A and B using what we call the Pythagoras theorem. But as we are going to learn that is in the Cartesian plane, of course, that is x and y, we are going to denote the displacement or the movement along the x and y axis using this. So this is a displacement in the y and a displacement in x, meaning that a displacement in the y is denoted or it just gives a movement along this y-axis. This is from the point, this point here, to this point here. This is what we are referring to as the change in y, while the displacement from this point, this is from this point to this one, this is what we're referring to as the change in x. So the relationship between the displacement in x and the displacement in y can be able to assist us find the distance between A and B, given that we know the properties of this particular line. So we are going to learn about the properties of a straight line. But for that case, this is a relationship that I want us to understand, that there's a relationship, given that there's a displacement in the x and y axis, there's a relationship that exists between the displacement of x, displacement of y, and then the distance between A and B. So this particular geometrical figure that we talked about, this is known as a right triangle. We're going to define different sets of triangle, like a scalene, a right triangle, isosceles, but for this case, this is known as a right triangle. Now for a right triangle, you find that that relationship that I've talked about of the displacement in x, y, and z, these particular portions of the right triangle have specific names, whereby this one is known as the base, or the width, and then this one is known as the height. Use a different so that we can be able to see. So this one is known as the height. This is known as the base, and this is known as the hypotenuse. So what I'm trying to say is that there's a relationship, there's a geometrical relationship between the base, the height, and the hypotenuse. And this basically develops the concept of the Pythagoras theorem, which I'm trying to mention here. So how do we illustrate these specific points on the Cartesian plane? So as I've said, that the Cartesian plane is a combination of points which entails the displacement in the x and y direction of the Cartesian plane. So if I say that there is a point A here, then I can denote point A as x and y. So giving the position of this point as x and y implies that I've given the coordinates. I've given the coordinates of point A, and then at point B, I can say that this is at point x1, y1. This actually implies the displacement in the x direction and the y direction, given as just point x and y. So what, of course, is going to, what we're going to look at is that we're just trying to expand the definition of this particular point from a geometrical aspect, in that it's going to give us the relationship between the displacement in x and y direction. Let me just do away with this. So as we mentioned, in just a nutshell, the concept of Pythagoras theorem, that is going to assist us find the displacement from A to B. So I can still just redraw that figure here, and we had a line, and then this is from A to B, and then we said we have points here. This was a right triangle, a right indicating that at that particular point is a right angle. So there was a displacement in x and displacement in y direction, and then the magnitude of A and B. So for that case, we said that we can represent the point A as x, y, while we can denote point B as x1, y1. And then we talked about the concept. Of course, let's Okay. So for that case, suppose we allocate numbers to this particular coordinates. I said we refer to this set of points as coordinates. So suppose we allocate numbers and say that x1 or just x, y, the point x, y is given by the figures of 3, 2. There is a displacement of 3 units to x direction and 2 the y direction for x, y respectively. And then for point B, this is for point A. For point B, there is an x1, y1 coordinate, and then we give them point 9, 4. So for us, since we have quantified these displacements in the x and y direction respectively, using the concept of the line that I've used for the number line, we can be able to find the change in y and change in x respectively. You see, from the change in x is cos x, the movement from x to x1. So this is the magnitude, as we said, and then the change in y can be y minus y1, the magnitude. So in this case, if we try to just fix the figures that we have, x represents 3, x1 represents 9, y represents 2, y1 represents 4. So the change in that, of course, is we're going to look at the magnitude of 3 minus 9, and then we have, this is 2 minus 4. So that's going to give us the magnitude means absolute value, which is a positive. This is 6, and then this is 2. So in that case, we can see that the displacement in the x direction is 6, and then the displacement in the y direction is 2 units. So now, Pythagoras theorem is a concept, of course, which I've said is a relationship between the 3 sides of a right triangle. And we're going to see that in this right triangle, the square of the hypotenuse, now this is a theorem, the square of the hypotenuse, our hypotenuse, let's say it is point, okay, this is AB, this is our hypotenuse, the length of the hypotenuse. The square of the hypotenuse side is equal to the sum of the squares of the 2 other sides. So this is the base and the height. So the claim is that, or the hypothesis is that, or the theorem is that the square of the hypotenuse is the sum means the total of the square of the 2 sides. Or maybe suppose I just put another point here, C, for just illustration. So we have triangle ABC. So the claim is that the hypothesis states that the square of AB is equivalent to the square of AC now. That it denotes the change in x direction. The square of AC plus the square of BC squared. So given some figures for this, of course, maybe either 2 sides, we can find the other remaining one, which is going to assist us find the magnitude of that specific line. So the Pythagoras theorem is very essential in this case, in that given the points of the coordinates of this Cartesian plane, of course, for the 2 set of points on a line, we are able to find the displacement of the missing aspect of that right triangle. So if we are given this side and this, then we can find this. Given this and this, then we can find this. So that's how simple it is. It's going to assist us. So for that case, it is good for us to just give a general definition, of course, for that. So generally for a right triangle, I've said that a right triangle is the one that consists of just of this form. whereby this is a 90 degrees. So suppose we have point A, B, and C, and we have said that we have been given the coordinates. Then we have said that Pythagoras theorem states that the square of the hypotenuse, this is point A to B, is equals the sum of the square of the other two sides. So AC squared plus BC squared. So generally this is what we refer to as the Pythagoras theorem. So suppose we say that this is point A, or maybe this is point C, this is B, this is point A. So generally using those lowercase letters, we can say that C squared is equals A squared plus B squared. So given one point, then we can be able to illustrate or demonstrate or just find the quantity of the other remaining part. So in that case, we have just tried to define some aspects of geometry and shortly looked at the concept of the Pythagoras theorem, which is going to assist us in trying to find the magnitude or the length of a line given the two sides. So for a quick recap, remember that as we illustrated a point, we have an aspect of a point, a line segment. Then basically we talked about a line. And then we have looked on how to find and how to define a straight line. And then we have talked about the Pythagoras theorem. Pythagoras theorem. The Pythagoras theorem. So we have talked about these different aspects as far as definition of our introduction to geometry is concerned. Now, as we can see that we shortly defined the term angle when we were talking about the right triangle, that at this point we have 90 degrees angle. Of course, we are going to look at other aspects of these angles and we're talking about, and slightly we talked about the Cartesian plane coordinates, which assisted us in finding the magnitude of the line that we are trying to look at. So in that case, this will form a basis for us in trying to discuss other aspects of geometry, which of course includes angles and planes, and maybe as we advance we're going to look at solids, of course, like the one that we brief for width, length and height, which are going to be borrowed heavily from what we have already discussed. So in a nutshell, that is the end of it. So for today, the introduction to geometry as a branch of mathematics, we shall stop there for today, guys. So let's meet in another video that we're going to discuss about angles and planes and other aspects of the geometry that we are going to look at. And as I have said, that these concepts that we have discussed here already are going to be borrowed, and then for that case it would be easier for us to understand, because I hope in our discussion you have got or you have understood one thing or two. So that is where we shall stop. Thank you for today. Bye. May God bless you.